Welcome to the solution video for the FizzBuzz challenge. Let's jump right in here and start with a console application. So File, New Project, select Console, not .NET Core, but instead let's go to Desktop and select Console App.NET Framework. It really wouldn't matter in this case too much because .NET Core works just fine, but I find that if you choose .NET Core now for this, then you might choose it for something else later. And I haven't really covered the differences yet, but there are some differences that would affect your project in future projects. So just for consistency's sake, choose the full .NET framework unless you have a reason not to. We'll move over to .NET Core in the near future. So let's call this the console UI, and we'll call the solution name the FizzBuzz solution. All right, when this creates, the first thing we'll do is create that console.readline. Now we're going to have a few different ways of tackling the solution. So let's start off with a simple one. The way I'm going to do this, I'm going to break these apart into their own methods. So private void, let's call this the simple solution. And really when tackling this challenge, this is probably the first place you should start. Now, some people really try to impress, especially if this is an actual interview, which usually this is no longer in interviews. But if it is, people try to impress by making a really complicated solution. But really what you need to do is show the simple solution first and then talk about your refactoring. At least that's my advice. If you come across as writing really complicated code that's hard to read and understand, then people are going to look at that and say that's representative of all your code and that your code will be difficult to understand. And that's not very good. So the idea is for the simple solution, we're going to go from 1 to 100. And if it's divisible by 3, we're going to say fizz. If it's divisible by 5, we're going to say buzz. And if it's both 3 and 5, we're going to say FizzBuzz. Otherwise, we're going to put just the number. So let's start off with a for loop. We're going to say I equals, we'll start off with 1. I'll change it in a minute, but I is less than 101. And the reason I said 101 here, and let's change the 0 to 1. This will now count from 1 to 100, because 100 is less than 101. Once it hits 101, it's going to eject itself out of the for loop. And that's the first place that people often get tripped up, is they either start at 0 instead of 1, or they go to I is less than 100 instead of 101. Other acceptable things to do would be to say less than or equal to 100. That would also work. Let's start off with our if statement. And again, we could inline these. I don't like that. I like to be clean and simple. So if I, then use the modulus, the percent sign, 3 equals 0. And what this does, this percent sign here, is it's going to do division. So I divided by 3, and it gives us the remainder. And in this case, the remainder should be 0 if we're going to have a match. And I modulus 5 equals 0. So this is our FizzBuzz solution. This is where we have both. Let's do a very simple console write line. I'll do my $, say FizzBuzz, and then parens, I'll have my I. Okay, so it's going to say FizzBuzz and then say 15 in parens. Okay, so that's FizzBuzz. And then I'll say else if I modulus, let's just do 3 equals 0. Then, now notice here that it's very, very similar, this one is, to this one, except I'm just checking for this first part, which means that this one will not be 0 if this one matches. We have an else if here. So in this case, it's just fizz. And I'll do another else if and say I modulus 5 equals 0. And so we're going to say this is just buzz. Okay, and one final else to say just I. So that's about as simple as you can get it. We're using the if, else, if to allow us to check first for the both case, in which case we say fizzbuzz. And then if that does not match, but one of these other two matches, they'll print out there. So fizz or buzz. And then if none of these are true, as in it's both have a remainder, that means that we just print out the number. So let's test this out. Simple solution. And actually static, that's why. If it doesn't show up in IntelliSense, there's a reason why. In this case, I forgot static. So private static void simple solution. Let's call that, and at the end we'll do that console read line. Let's start this up. I'll move it to the middle of the screen. And let's go to the top. We have 1, 2, fizz is 3, 4, buzz is 5, fizz is 6, because 6 divided by 3 is 2. And then you come all the way down here to 15, now we have a fizz buzz. Now 30 is a fizz buzz, 45, and so on. All the way down to 98, 99, and 100. So we have a 1 to 100, which is exactly what we're looking for. So that's our simple solution. Very quick to write, very easy to write. It's not complicated. It's not anything you have to look at and go, what's going on here? There's using the modulus, but that's about it. Otherwise, you're good to go. So now let's do that one refactoring I talked about, where we don't have to do this division multiple times. So see how we're doing this division right here and right here. Then the same division as here, right down here, and the same division here as we have up here. So let's improve this. I'm going to copy this. I'll shrink down this. And I'm going to say private static void refactored simple solution. Now I'll paste this in. I'm going to do some modifications. First, let's create a couple of variables here. Bool is fizz equals false. And bool is buzz equals false. Now, inside the for loop, I'm going to take these calculations. So let's grab this one first. This is fizz. And say is fizz equals this, the value of the if statement here. Now remember that an if statement evaluates to either true or false. So I'm going to grab the whole thing and paste it here. Now I don't technically need the parens, but I'm going to leave them there. That way it's just very, very clear what's going on here. And we know this whole thing is getting evaluated. And then that's either true or false. Now is buzz. And I'll take this right here. And there we go. There's the result for buzz. Now I can say is fizz and is buzz. Is fizz is buzz. Okay, so now I refactored it just a little bit. I've tweaked it, and now we're doing this division once. Once for fizz, once for buzz, because obviously divisions are different. But now I can check for is fizz more than once and use the same value, so we're not reevaluating. Okay, so that makes it a little bit better. That's a nice little refactor, just to save a few cycles. Now, the reality is we're not saving a ton, but it does show that you're thinking through the idea of reuse of a value instead of recalculating every time. And you kind of show that you know what you're talking about when it's with Booleans. So notice also here, I didn't say equals true. I could have, it's a little more clear, but at the same time, I named them well. So is fizz and is buzz just reads really nice. else if is fizz, that reads really nice. You understand what it's about. Okay? So there is the refactored simple solution. And just to prove that this works, let's go ahead and run this. I'll hit start. I'll move it up. And the same stuff is happening. So there's fizz, buzz, all the rest. And 100, the top one is 1. So now let's move on to the more advanced stuff and talk about the next one. So we'll say private, static, void, and let's call this the reusable refactor. Okay, so we're going to kind of reuse this or make it a little bit more flexible. Let's call it flexible refactor. The next one's more reusable. And we're going to say here, let's take in the lower bounds and the upper bounds. That allows us to say things like 0 to 120 or negative 10 to positive 10 or whatever we want. Now, the other thing I want to do is I want to set up where we can add multiple different things. So we have fizz is 3, buzz is 5. We want to add that jazz is 7. But we don't want to keep doing all these different else if statements. So let's create a dictionary of type int string. And we'll call this rules. Now, what a dictionary allows us to do is create a unique key. So this would be, in this case, 357, and then a value to associate with it. So fizz, buzz, and jazz. So let's create 3 rules. Rules.add. 3 for fizz. Rules.add 5 for buzz. And then rules.add 7 for jazz. All right, so now it's time for our for each or for loop. So for, so we'll say I is less than, we're going to change all of this. We'll say upper bounds is what it's less than or equal to, and I equals lower bounds. So we're going to start from lower bounds and move to the upper bounds and use the less than or equal to so that if we pass in 1 to 100, it actually goes to 100, not 99. Again, that's one of those tricky bits to remember with a for loop. So now inside here, I'm going to say string result equals an empty string. Now, here's the one that you might have missed. If I equals 0. This is the one that does not act the way we expect it to. I'm going to say console write line 0 and then continue. So why is this? Well, if you do 0 modulus 3, it's going to return back 0 because the remainder of 0 divided by 3 is 0. There's no remainder. But does not mean that I is divisible by, or 0 is divisible by 3. It's really not. It's 0. So we want to take this one out and say, well, it doesn't really apply to our normal rules. So therefore, 0 is its own special case. So instead of saying fizz, buzz, jazz, which is what it would calculate to, instead we're going to say, nope, print out 0 and then continue. Now, if you're not familiar, what continue does is it says, stop processing this version of I. Move on to the next one. So it's not breaking out the for loop entirely. It's just saying this current iteration is done. That means the rest of the code below here will not run if it's 0, but otherwise it will. All right, so there's our one special case. Now we can do is do a for each. I'm going to say var here, rule in rules. Now, normally I like to specify what the type is, but in this case, it's a key value pair of type int string. Just easier to leave it as var. So for each rule in the rules, if I modulus rule.key. Remember the key is? The key is that 3, 5, 7, or whatever else. Equals 0. So it's an int, so we can still do that. If it's equal to 0, say result plus equals rule.value, as in fizz, buzz, or jazz. So that's our string right here. Now, if result.length is greater than 0, console write line, have our $, immediately do a result, which we fizz, buzz, jazz, or fizz, buzz, jazz. And then we'll put inside parens the actual number. Else, whoops, that's not else. There we go. Else, we'll say console write line and just I. Okay, so you catch all that? It's not much more code, but at the same time, it's a lot more flexible. We can add in as many rules as we want, and the same system works. Where it's going to do a for each over every rule. We work on the lower bounds and the upper bounds, and we process through, and it's going to find them in order, and it's going to say, okay, fizz, buzz, jazz, and it's going to print out each one that it finds. So it's going to append them. And if it finds nothing, then it prints out just the number. Now, I am putting these rules in here in this flexible refactor, but I could pass these in as well. And that's very flexible. So let's call this flexible refactor, and let's start off at 0 to 120. Let's run this. And as you may notice, we now have fizz, buzz, jazz right here. We have jazz down here. There's a lot more that are filled in. That's one of the reasons why I had you put the numbers in parens, because they start to fill in a lot more. All the way through 120. The first one is 0, and it is 0, not fizz, buzz, jazz. Now notice down here, fizz, jazz, 21. So we got all the different combinations working. We've got the full fizz, buzz, jazz, and we have 0 taken care of. That's a pretty flexible refactoring. And like I said, I would probably even pass in these rules. I just didn't make it a little more clean to call it by not making us do it up in our main. So this, I think, would be the best solution so far, for sure. And it's probably also the simplest one for attacking this problem in its current state. Now, there's a few limitations we have here. First of all, you have to be okay with the idea that we say fizz buzz or fizz jazz or buzz jazz or fizz buzz jazz in that order when we find ones that match multiple. But what if you wanted to tweak things and say, well, I actually want this to happen or that to happen? And also, right now, we're tied to the console. So how do we use this in WinForms? Well, we refactor the entire thing. So there's a few limitations here. So let's tackle the next one, which is much more complicated. And don't get scared by that, because this is very, very simple. But it's more complicated, let's put it that way. And yet it's much more able to be used longer term or used in other areas. So let's start off, instead of creating the actual method, the first thing I'm going to do is actually create a sub method I'll be using. So let's say private static bool is divisible. Let's say num is divisible by. And we'll say int num and int array values. Okay, so what's going to happen is we're going to pass in a series of values. So let's say 3, 5, 7 in an array, or 3 and 5, or 3 and 7. And say is divisible by, and we're going to say bool output equals true. Normally I'd say output equals false, but this one's a little bit different. And the reason why is because we only have to find out that's not divisible by one of them to say, no, it doesn't work. So therefore, I'm going to do a check, and if any of them fail, I'm going to say that everything fails. So let's do for I equals 0. I is less than values dot length. Okay, so we're going to loop through every value here in this list and say if num, which is the original number that we're finding out if it's divisible by 3, 5, 7, whatever, num modulus values at position I is not equal to 0, output equals false. Now, we should probably also say here break. And what that'll do is it will break the for loop. It's a little bit of a time saver, not much, but some. So if you had, let's just say 10,000 values here, which way overkill, okay? We're talking about normally maybe 1, 2, 3, or 4 values passed in. But if you had 10,000 values and you found the very first one that output would be false, you don't need to check all the rest. So you hit break, that exits out of the for loop entirely. Return output. So normally, if this is not right at all, it's going to return true. But when this runs through, if it finds anything that's not returning 0 as the remainder, then it's going to say false for the output, break, which returns here, which returns false. So this is our little check right here to check and see if something is divisible by those other numbers or not. Now let's move on to our actual project. Actually, let's do one more thing real quick. Outside of my class, I'm going to create a public struct. Now, normally I don't use structs. I use classes instead, but I'm going to use a struct here because I want the value type. It's simple. I'm not doing a whole lot with it. I just wanted to hold a couple of values together. Divisible rule info. That's what I'm going to call it. And I'll say public string word to print and public int array must be divisible by set. And I'll have a constructor to make things a little easier. And in this constructor, I will pass in the word and the number set. Oops. And then I'll say that word to print equals word and must be divisible by set equals number set. Okay, real simple stuff. It's a little struct here. If you're not familiar with structs, they're essentially classes. The difference is a class is an object type and a struct is a value type. And so this makes it a little bit smaller and a little bit easier. It's basically just glue to hold a couple of different types together. In this case, these two types. Now, I've put it in the same program.cs as my main. I'll take it out, but for now I'm going to declare it here, and then I'm going to move it. So what I'll do is I'll come here and say, go ahead and move to divisible rule info.cs. I'll do that once I'm done, but I like having it here so we can see it. Okay, now I'm ready. Private, static, void, reusable, refactor. And we'll take in a list of this divisible rule info called rules and we'll say int lower bounds like before, and int upper bounds. So here I am going to pass in the rules so that this can be reused entirely. So let's do our for loop. And a similar kind of thing here. I is less than or equal to is essentially it's going to be upper bounds. So less than or equal to, and I is equal to lower bounds. So I equals lower bounds, I is less than or equal to upper bounds, I plus plus. We're going to have a bool here for is found equals false. And then we're going to do our check for our I. If I equals 0, then this is where normally I'd put a console write line. That's what I did last time in this flexible refactor. I put a console write line right here. But that doesn't seem like a good idea because, like I said, I want to get away from the idea of being tied to that console. So let's do this. Let's, instead of returning void, let's return a list of string. I'm going to have a list of string called output. And I'll say that output.add, and it's the same stuff I'll put into what I would put in the console write line. So in this case, I'll put 0. Now I can't do like that. I gotta put it in quotes. Or I could have said that 0 to string, but it makes more sense just to put in quotes. And then here, I'm going to do a continue. I want to go to the next one in the for loop, just like before. All right, so now I have a for each. I'll say again, var rule in rules, just like before. This time, if, and I'll check num is divisible by, I'll pass in I, and then the values that I pass in are rule dot must be divisible by set. So that's whatever the set of numbers we divisible by. And I say that if it is, then I'm going to say, instead of console write line, we'll say output.add. I'll have that same $sign syntax, the string interpolation. I will say rule.word to print. And again, afterwards, in parens, I'll put our number, which is I. Okay, and I'm going to say is found equals true. Break. Now what I'll do is down here after the for each, I'm going to say if is found equals false. Now I could have said bang is found, like the exclamation point, like so, and then not had this. The problem with that I have found is it's easy to miss this. It's such a small little character that it's hard for me to scan through and read that. So I like to say is found equals false. It's a little more explicit. It's the same difference when it comes to the compiler itself. So it's just a matter of which you like to read. And since code is meant to be read by humans, I find it easier. This pops out a little more. Is found equals false. So not console write line. We're going to say output.add, and it'll put I.toString. Okay, so the reason I did this is because I don't know if that last one in the list we found it or not. Okay, so I'm going to do a for each and say the first one I find, I mark it as found and then break, which gets us out of the for each entirely. So the purpose behind this is we're going to go through our list of rules from top to bottom. one at a time. Okay, so now what I'm going to do is I'm going to call this reusable refactor, but I have to first set up a few things, like a list of divisible by or divisible rule info called rules equals new list. And now I need to create some rules. After I create the rules, then I'll say reusable refactor, pass in the rules, and then the lower bounds, let's put it at 0, and the upper bounds, let's put it at 120 again. Now, just with this, if we were to run this, we get nothing because I have to capture the output. So we can say var results equals, and then we can do a for each result in results, and then just do a console write line with result. There we go. That should do us. And if we run this, notice that there's just 0 through 120. We didn't put any rules in place. So let's put some rules in place now that we have our call working. So let's say rules.add. Let's add some simple rules first. So new, and this is our struct, and we'll call the constructor. So let's just do fizz. And then we're going to pass in a new array with just fizz is 3, so like that. So there's fizz. Let's copy this and paste it and make buzz and say 5. Now remember I said that these are going to get run in order. So we find fizz first, it's going to stop there. Let's just run this and see this in action. All right, so there's through 120. Notice that for 15, it says fizz, not fizzbuzz, because fizz is first in line. It found that fizz is true, therefore it stopped right there. It didn't check for buzz as well. So let's add a rule for fizzbuzz. Let's paste our rules in and say fizzbuzz, where both 3 and 5 match. Let's write again. And now notice 105, fizzbuzz. Okay, so there's our rule set. And again, priority matters. The first one to go in is the one that's most important. The last one to go in is the least important. So let's add a few more. For example, let's just go right to fizzbuzz jazz. So I'm going to copy this actually and paste it in and add fizzbuzz jazz. Well, fizzbuzz jazz is 3, 5, and 7. Now, if we run this, now we see the 105 fizzbuzz jazz. Okay, so we're making some progress. Now we can start adding our different permutations in or even changing things entirely. So the previous solution worked this way in a different way, but it still got the same results. But what if instead of fizzbuzz jazz, you want to say pizzazz? So 3, 5, and 7, not fizzbuzz jazz, it's pizzazz. With this one, not a problem. 105 is now pizzazz. Okay, with the previous one, we'd only add fizz, buzz, and jazz together. Therefore, we couldn't handle that type of scenario. We're more flexible now. Now we can add other rules as well. For example, if we want to handle the fizz jazz and buzz jazz, we could handle those as well. So fizz jazz would be 3 and 7, whereas buzz jazz is 5 and 7. And now we have those as well. So we have fizzbuzz, we have pizzazz, we have fizzbuzz, we have fizz jazz, to deal with looping and, very simple algorithms as well. Okay? Thanks for watching.